NENOMATICA, where mathematics meets YouTube excellence. Welcome to this math tutorial. Today we'll learn how to factor polynomial expressions using a specific method for trinomials that aren't perfect squares. Before we start with our example, let's understand the general approach. When we have a second-degree polynomial that doesn't have a perfect square, we'll multiply and divide by the coefficient of the squared term to help us factor it completely. Now, let's look at an important note. If the coefficient of the second-degree term is not a perfect square, we'll multiply and divide by the coefficient to help us create a perfect square pattern. Then we can apply the difference of squares formula or other factoring techniques. Let's work through our example. We need to factor the expression 3x squared plus 2x minus 8. Step 1. We'll start by rewriting the expression with a factor of 1/3 pulled out from the entire expression. This gives us 1/3 times the quantity 3 times 3x squared plus 2x minus 8. Step 2. We'll multiply the terms inside the bracket. 1/3 times 3 is 1, and then we have 9x squared plus 6x minus 24. Step 3. Let's look at what we have inside the parentheses. We can rewrite this as 3x squared plus 2 times 3x plus 6 times negative 4. We're trying to express this in a form that's easier to factor. Step 4. Let's rewrite this again in a way that will help us factor. We'll use the pattern for factoring a trinomial. We have 1/3 times the quantity 3x squared plus 6 minus 4 times 3x plus 6 times negative 4. Step 5. Let's simplify inside the brackets. 6 minus 4 equals 2, so we have 3x squared plus 2 times 3x plus 6 times negative 4, which is negative 24. Step 6. Now we can factor this expression by grouping. We have 1/3 times the quantity 3x plus 6 times the quantity 3x minus 4. Step 7. We can simplify this further by factoring out common terms from each parenthesis. From the first parenthesis, we can factor out 3, giving us 3 times x plus 2. The second parenthesis remains the same. Final step. Now we can simplify the expression completely, the 1/3, and the first 3 cancel out, giving us x plus 2 times 3x minus 4. So the factored form of our original expression, 3x squared plus 2x minus 8, is x plus 2 times 3x minus 4. Let's summarize what we've learned. We started with the expression 3x squared plus 2x minus 8. We multiplied and divided by 3 to help create a factorable pattern. We rearranged the terms to identify a pattern that could be factored. We used factoring by grouping to find the factors. And we simplified to get our final answer, x plus 2 times 3x minus 4. Remember, this technique is very useful when working with polynomials that have coefficients other than 1 for the squared term. By factoring out the coefficient and working with the resulting expression, we can often find the factors more easily. Let's look at our example. Let's begin our factorization process. In the first step, we'll factor out 1/2 from the expression. This is an algebraic trick that will make the leading coefficient easier to work with. Now, let's simplify the expression inside the brackets by multiplying 2 into each term. 2 times 2x squared gives us 4x squared. 2 times 5x gives us 10x. And 2 times negative 3 gives us negative 6. In the third step, we'll rewrite our expression to prepare for factoring. We'll express the first term as the square of 2x, which is 2x squared. For the middle term, we'll write it as 5 times 2x. And for the last term, we'll rewrite negative 6 as 6 times negative 1. Next, we'll rewrite the middle term to prepare for completing the square. We need to convert 5 times 2x into a form with 6 minus 1. So we get 2x squared plus 6 minus 1 times 2x plus 6 times negative 1. Now we'll group our terms to set up for factorization. We can write this as 1/2 times the expression 2x plus 6 times 2x minus 1. This grouping will help us identify our factors. In the sixth step, we'll simplify the first factor. 2x plus 6 can be written as 2 times x plus 3. This gives us 1/2 times 2 times x plus 3 times 2x minus 1. In our final simplification step, the 1/2 and the 2 cancel out, leaving us with x plus 3 times 2x minus 1. So our final answer is x plus 3 times 2x minus 1. This is the factored form of the original expression 2x squared plus 5x minus 3. Let's summarize what we've learned. First, we factored out 1/2 to make the leading coefficient more manageable. Then, we simplified the expression inside the brackets. Next, we rewrote the expression to identify the structure that would lead to factorization. We manipulated the terms to match the pattern of a perfect square trinomial. Finally, we simplified our factorization to get the final answer. This technique of factoring quadratic expressions is very useful in algebra and calculus. Practice with more examples to master this skill. We'll be working through a step-by-step process to factor the expression 3x squared plus 5x minus 2. Let's begin with our first step. We'll factor out the coefficient of x squared, which is 3. To do this, we rewrite the expression as 1/3 times 3 times the original expression. So we have 1/3 times the quantity 3 times the quantity x squared plus 5x minus 2. For our second step, we'll distribute the 3 inside the brackets. When we distribute the 3, we get 1/3 times the quantity 9x squared plus 15x minus 6. This is an important step because we're preparing to factor the expression inside the brackets. For our third step, let's prepare to use the pattern recognition for factoring. We'll rewrite the expression inside the brackets in the form of a squared plus b times a plus c. So we get 1/3 times the quantity 3x squared plus 5 times 3x plus 6 times -1. For our fourth step, we need to adjust the middle term to fit a perfect factorization pattern. We'll rewrite 5 as 6 minus 1 to help us factor. So our expression becomes 1/3 times the quantity 3x squared plus 6 minus 1 times 3x plus 6 times -1. For our fifth step, we'll group the terms to prepare for factorization. Let's distribute the middle term and rearrange. So we get 1/3 times the quantity 3x squared plus 6 times 3x minus 1 times 3x plus 6 times -1. For our sixth step, we'll reorganize the terms to identify common factors. We can group the first two terms and the last two terms. So we get 1/3 times the quantity 3x times 3x plus 6 plus -1 times 3x plus 6 times -1. Now we can factor out the common terms from each group. For our seventh step, we'll factor out the common term from both groups. We can see that 3x plus 6 is common to both groups. So we get 1/3 times the quantity 3x plus 6 times the quantity 3x plus -1. This gives us 1/3 times 3x plus 6 times 3x minus 1. For our eighth step, we'll simplify the first factor. We can factor out a 3 from 3x plus 6. So we get 1/3 times the quantity 3 times the quantity x plus 2 times 3x minus 1. This simplifies to 1/3 times 3 times x plus 2 times 3x minus 1. For our final step, we'll simplify the fraction with the coefficient. 1/3 times 3 equals 1, so we can cancel these terms. Our final factored form is x plus 2 times 3x minus 1. Let's look at our example. We'll start by factoring out 1/6 from the expression. This will help us rewrite the expression in a form that's easier to factor later. Next, we'll distribute the factor of 6 inside the brackets to expand the expression. Now, let's rewrite our expression in the form that prepares us for factoring by grouping. We'll rewrite it to highlight the terms we can work with. We'll continue by rewriting our expression to prepare for factoring. We'll break down the middle term to help us identify the factoring pattern. Now, we can further simplify our expression by rearranging the terms. This will help us identify a common factor in preparation for our final factorization. Now we can factor out common terms from groups of terms. This step reveals the pattern that will lead to our factorized expression. Let's simplify our factorization by factoring out the greatest common factor from each factor. Let's continue simplifying our factors by factoring out any common terms from the second factor. Let's start with our example. We want to factor the following expression: 2x squared plus 7x plus 3. The first step in our factoring process is to multiply the entire expression by the leading coefficient, which is 2 in this case. So we get 1/2 times the quantity 2 times the expression 2x squared plus 7x plus 3. Next, we'll distribute the leading coefficient 2 to each term inside the parentheses. This gives us 1/2 times the quantity 4x squared plus 14x plus 6. Now, We'll rewrite this in a form that makes it easier to factor. We're looking for a pattern in the form of a squared plus b times a plus c. In our case, we can rewrite it as 1/2 times the quantity 2x squared plus 2 times 7 times 2x plus 6. To better prepare for factoring, let's rewrite this again to highlight the pattern. We have 1/2 times the quantity 2x squared plus 7 times 2x plus 6. We can think of this as having the variable 2x instead of just x. The next step is very important. We need to identify that 7 can be written as 6 plus 1. We're doing this because we're looking for a pattern of the form a squared plus b times a plus c, where b and c have a special relationship that allows us to factor. Specifically, we're looking for the pattern where the middle coefficient can be split in a way that helps us factor. Now we can regroup the terms to create a factored form. 1/2 times the quantity 2x squared plus 6 times 2x plus 1 times 2x plus 6 times 1. The next step is to factor out common terms from each group. From the first group, we can factor out 2x, and from the second group, we can factor out 1. This gives us 1/2 times the quantity 2x times 2x plus 6 plus 1 times 2x plus 6. Now we can see that both terms have a common factor of 2x plus 6. So we can factor this out, giving us 1/2 times the quantity 2x plus 6 times the quantity 2x plus 1. Let's simplify the first factor. 2x plus 6 equals 2 times quantity x plus 3. So our expression becomes 1/2 times 2 times the quantity x plus 3 times the quantity 2x plus 1. Finally, we can simplify the expression. 1/2 times 2 equals 1. So our final factored form is the quantity x plus 3 times the quantity 2x plus 1. Let's review what we've learned. To factor a quadratic expression of the form ax squared plus bx plus c, we can use this method of multiplying by the leading coefficient and then finding a pattern that allows us to factor. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.